So a friend of mine works on guitar amplifiers, and he saw a video of another YouTuber, and in that video the YouTuber showed the transformer turns rate tester. And so my friend contacted him because he said he may have some for sale, and that YouTuber never got back to my friend. So my friend said, can you make me a transformer turns rate or turns ratio tester? And I looked at the video, and the YouTuber used analog meters. And if you look on eBay, analog meters aren't exactly cheap, and they're not as accurate as digital meters. So I decided, hey, why don't we just make him something that you could use with a multimeter or a scope. And the multimeter that you have to use will have to be able to go down into the millivolts AC, and it has to be a true RMS multimeter. A cheap meter won't work, but I know he's got a true RMS multimeter, and I know he's got an O-scope. So the multimeter will hook up on these terminals, and you can hook up an O-scope on these terminals. This thing works rather well. I'm rather impressed with it, and it just consists of a couple simple parts. It has a signal generator inside. It's run off a 9-volt supply, and it's only got 2 boards in it. It's got a 555 generator, so it'll generate a square wave, and I set it to 1,000 hertz. And then that you have a resistor, a comparative network that turns that square wave into a sine wave, which I'll show later in the schematics. And then that goes to a simple LM386 amplifier board that can also be bought on eBay. Both of these, might run you about $10. In addition to that, you need a couple BNC connectors. You need a couple jack connectors, a couple banana plugs, and a T, because I'll show this later, but the T you can use to do frequency checks with the thing. So all in all, this came out, like I said, rather nice. So we'll demonstrate how it's used right now. All right, so in this test, this is a speaker test. We're going to set the power to off. It's off. Cal sine to sine. Sine. ISO sig to sig. ISO sig to sig. Connect the multimeter to the AJAX and set to read VAC. So we've connected to the AJAX here, and we're set to read voltage AC. Now what this does is there's a precision 100 ohm resistor on the end of the signal generator inside. So with the meter there, you're setting approximately 10 millivolts per ohm when you set this to 1 volts RMS. So we're going to set this to 1 volt RMS, and then we're going to hook up the speaker over here on the meter side, not changing the circuit, and we'll be able to read the speaker ohms. So we're going to turn the power on. And we're going to set our signal generator to around 1 volt RMS. That's pretty close right there. Okay. So now I'm going to take this speaker and hook it up to the speaker jacks. So here you can hear a tone. And on the meter, we have 88 millivolts. So if we just move this decimal point 1 over divided by 10, that speaker's reading about 8.8 ohms with 1,000 hertz. And you can tell the speaker works, and it's pretty close to the 8 ohm rated speaker, plus or minus 1 ohm. So say we don't like that one. Say we want to test another one. All right, so I have a miniature little speaker here. Can't really read this stuff on the back, but we're going to go ahead and hook it up. It's not complying. Again, we hear the tone. It's reading 7.64 for this speaker. Okay, cool. Let's try another one. Now this one's kind of beat up because it's been thrown around the box, but we'll hook it up anyway. Again, we hear the tone. And note this time it says 4.34, so that would mean, or 43.4, move the decimal over, 4.34. Well, is this 8 ohm or 4 ohm? Look at that, it's a 4 ohm. Got one more. It's a Dayton audio exciter. We're going to go ahead and hook this exciter up and see what it reads. Can't hear much noise because it's an exciter. You almost have to put something on it, but it says 45.1, divide that by 10, you got 4.52. And there, if you put something on it, you can hear the tone. That's how these exciters work. So that's pretty neat. And at some point I was wondering, well, could you measure a crossover? Could you measure the input impedance of a crossover? So I went on eBay and I bought this crossover, not exactly knowing what it was. I thought it was a two-way, but it's not. I had to do some investigation later. But if we hook the crossover up, I got a weird reading of 2.41, which would be 2.41 ohms. But at this point, we have no load connected. So I connected an 8 ohm load, and it didn't look right. It came up a little bit. And then I looked at the crossover, and I was like, well, both these are in parallel. So let's assume that we have two 8 ohm speakers in parallel, and the tweeter at this point doesn't matter because it's not going to be crossing over at 1,000 hertz. It's going to be infinite resistance to that. So we go ahead and let's hook 4 ohms up as a load. This is a 4 ohm resistor. So we're just going to use a 4 ohm resistor. We could use one of the 4 ohm speakers, but it's easier to hook a resistor up. So if we hook a 4 ohm resistor up, which would be equivalent to two 8 ohm speakers, we get 5.51. And I'm like, wow, that's really weird. But interestingly enough, I did some research on where this crossover came from. And here, I don't know if you can see it. It says NUMI CS5R01. Well, it turns out that was a center speaker for surround sound. And I bet you can't guess what the input impedance was on it. I'll show you in a second, but it said, the back of the speaker says 6 ohms. So pretty much you can test the impedance of a crossover. And we're going to show how to use this thing just as a jack setup so that you can check the crossover frequencies out. But that's it for the speakers.